Hi, welcome back. Hononegah, Algebra 1, 6.4, exponential growth and decay. This one is dealing with the formulas involving exponential growth and decay, and these formulas will be given to you, but they're pretty easy. It's a pretty easy formula to deal with, and so with that being said, let's get started. Y is equal to A, parentheses 1 plus r raised to the t. And notice the other side is y is equal to A, 1 minus r raised to the t. So as I do one column, you actually can kind of do this for both. So y in this particular formula is the end amount, like how much you're going to end up with when it's all said and done, which makes A then the initial amount. Now, sometimes that's referred to as the principal amount. R. Now, here's where things get a little bit different. R is the rate. Now, a lot of times they will give you the rate as a percent. And so when you put it in this particular formula, you need the rate as a decimal. So if I said 3%, that's the same as 0.03 as a decimal. So again, R is rate as a decimal. So you need to be careful there that you need to turn your percentages into a decimal. T is time. Now, it's the same thing over here. It's the end amount, initial amount, but here's the one that I kind of want to talk about. If you are growing, like there's something that's going up, this is a positive rate. So notice it's plus the R. And when you're decaying, it's a negative rate. So that would be the one thing that I would talk about when you're plugging it in. It's one either minus R or it's one plus R, depending on whether or not you're growing or decaying. And this is still time. And all of that is being said right here. Initial amount, final amount, R is the rate as a decimal, T is time, and then that is the growth factor. And that's the one thing that we're going to talk about then just a little bit. So there's the rate of increase or the rate of decrease, and then there's what's called the growth factor. And there's actually called a decay factor as well, but that is what's actually in the parentheses. So after I have actually added the rate, then that turns into 1 plus. So the growth factor is 1 plus the R. So here we go. Maybe. Same thing as decay factor. Identify the initial amount A and the rate the rate of the growth R as a percent of the exponential function and then evaluate. So here's what they want. They want to know what is the initial amount. The A value in this case is 350. So we can do that with each one of these. The A value would be 6.72. The A value would be 25. So again, I've done all of these. What is the initial amount? Now, the harder part. What is the rate? Notice 1 plus 0.75. So 0.75 is the rate. As a percent, that's 75%. The next one. So what I always tell everybody, if I know the rate is above 1, this is 1 plus R. So what would the rate actually be? Well, I'd subtract 1, and the rate would be 1, or 100%. And so the last one, 1 plus R is 1.2. So if I subtract 1, I get 0.2, which is 20%. So I did each one of those. Last one says T is 5. So this is a calculator exercise. In my calculator, I want to be able to type in 350, parentheses 1 plus 0.75, and then I want that parenthesis raised to the fifth. So I'm going to pull out a calculator, and we're going to do this. So 350, 1 plus 0.75 raised to the, and again, depending on how old or new your calculator is, depending on whether or not it actually writes it as an exponent, to the fifth. And then you're just going to hit enter and write down the answer. 5,744.58. So 5,744.58 was the answer to the first one. So let's do the next one. 6.72 and then 2 raised to the fifth. So 672. Oops, we're going to clear this again. 672, 2 raised to the fifth. And now this one's going to go up pretty quickly. 21,504. Oh, my bad. Hold on. It wasn't 672, it's 6.72. Let me try that again. 6.72 times 2 raised to the fifth power. So 215.04. My apologies there. So 215.04. Last one. Let's see if you can do this one by yourself. So go ahead, hit pause. All right, here we go. 25 parentheses 1.2 raised to the fifth. 25 1.2 raised to the fifth power. 62.208. 62.208. So there were 3 questions they asked. I'm going to circle each one of those here in this last one. What is the initial value? What is the rate as a percent? And what is the value when you put 5? And they did ask me to round to the nearest tenth. I know I didn't do that on each one of these, but again, you probably should follow directions there. Write the function that represents the situation. All right, the sale of $10,000 increased by 65%. So A1 plus R raised to the T. So I have Y equals 10,000. That's my initial amount. 1 plus 0.65 raised to the T. So that is the model. Every time I ask you to do the model, I accept this answer. Some teachers are going to require you to go ahead and write out the growth factor, which means adding the 2 together. So again, 10,000, 1.65 raised to the T. The next one, we're starting off with 210,000. We're increasing by, now, 2 decimal places. Remember, that's a percent. Changing it into a decimal, raised to the T. I accept that answer. Some teachers are going to make you go ahead and add the 1 plus the rate and turn it into the growth factor. And so that's the model. Growth word problems now. You deposit $1,400 in an account. And again, we're using the exact same formula every time here. So we're putting $1,400, the initial amount. 1 plus 0.06, 6% written as a decimal, raised to the 8th. And now they want me to go ahead and find this. Again, if you want to go ahead and add the 1 plus 0.06, sorry, you can. You just don't need to. When you're typing it into the calculator, you can leave it as 1 plus 0.06. So let's pull out a calculator. 1,400, 1 plus 0.06 raised to the 8th. So 1,400 times 1 plus 0.06, and as I described before, you can go ahead and add that if you want, raised to the 8th power. So on your calculator, I got 2,231.384. So I don't know if it asked me to round to the nearest tenth or not, but it's money, I believe. So $2,231.39. $2,239.31, if I remember right. So I'm going to go back to my calculator here. 223931. 223139. I apologize. Wish I could toggle back and forth a little better. There we go. You deposit $300 into an account. So $300. It pays you 5% interest over the course of 5 years. So there is there's the model, and we put 5 in for T, and so now I'm going to pull out a calculator again. 300, 1.05 raised to the 5th. So 300, 1.05 raised to the 5th power. 382.88. 382.88. And the last one, you deposit $900 into an account. Find the balance after 10 years if the interest, again, is 5%. So it's the same 5%, but now we're going 10 years, and we started off with more money. So 900, 1.05. Now, you could have wrote that as 1 plus 0.05 as well, raised to the 10th. $1,466.01. 1466.1. 1 cent. Next one. Identify the initial amount A. So now we're going to do the exact same thing we just did. I'll do these one at a time this time, but This one's a little harder, so I'm going to slow down. The initial amount is 575. That is not something usually everybody has trouble with. 1 minus r, because remember, the value now is below 1. We are subtracting the rate. And so in this case, 0.6 is the rate, which is 60%, written as a percentage. Now, they want me to plug in, 1 minus. So now 575, I'm kind of going back here, so if it jumped a little bit, I apologize. 1 minus 0.06 raised to the third power. So we're going to type that into our calculator. So there's 3 answers we're going to get. One was the initial amount, one was the percent or the rate, and then typing that into our calculator, we're going to type in 575, 1 minus 0.6 raised to the third power. And so the answer to this question is 36.8. So I'm going to go back to and write 36.8. So there's 3 answers to the question. Next one, the initial amount. There's no number in front. So the initial amount is actually 1. So that's a little confusing for some people. Now, 1 minus r equals 7/8. This is the best way for me to describe how to find r. If it's something that's above 1, you're going to use 1 plus r to find the rate. If it's below 1, you're going to use 1 minus r to find the rate. And so the rate in this case is 1/8. Now, they want it as a percent, so I'm going to have to turn this into a decimal. So I'm going to turn the fraction into a decimal, and then I'm going to turn the decimal into a percent. So 1/8 as a decimal is 0.125, which gets me 12.5, and I don't know why I just messed that up, 1.25, 12.5%. So there's my rate, here's my initial value, and now they want me to actually put 3 in for t. So I pull out my graphing calculator again. I want 7/8, so 7 divided by 8, raised to the third power. And so the answer is 0.67 if I round to 2 decimal places, which I'm not sure. Oh, they asked to round to the nearest tenth. So 0.7 would be the answer then that they would expect. If you wrote it as you could also do it as a fraction, but not necessary. All right, try this next one all by yourself. So hit pause and see if you can do it. All right, welcome back. So there's 3 answers they want. What is A? That's 240. What is R? Remember, 1 minus R is equal to 0.75, or 1 minus R is equal to the decay factor. Subtracting 1, I get 0.25, which is 25%. Now they want me to put 3 in for t. So 240.75 raised to the third. So 240.75 raised to the third. So 101.25, and if I rounded to the nearest tenth, you'd have 101.3. And those are your 3 answers. Word problems. Now, some things actually go down instead of up. So we are still using the formula 1 minus r raised to t. So if I start off with 100,000 people. This is called a model, by the way. 1 minus 0.02, the rate as a decimal, to the t. So you can leave it this way. My class, if you have another teacher that is expecting you to go ahead and subtract there, then we have 100,000. Oops, I'm missing a 0, aren't I? 100,000.98 raised to t. Next one, we got stocks that start off with $100. 1 minus 0.095 raised to the t. Again, I will let my class leave that as their model. If you go 0.905, that would also be your model. Next, we're going to do some calculator work then. Now we're going to actually do our models, and we're going to put in a number. So you buy a used car for $20,000. So y equals 20,000. 1 minus, it goes to appreciates at a value to 7% per year. So here's the model. Now, they want me to plug in two values here. They want me to plug in a $20,000 vehicle for 8 years. And what would my $20,000 vehicle be? Oops, one too many zeros there. For 12 years. So I'm going to go back to my graphing calculator. I'm going to do both of these at the same time. So I've got 20,000 1 minus 0.07 raised to the 8th. So I'm going to write that answer down here in just a minute. And then I'm going to do the same 20,000 one too many zeros. I know somebody's probably saying that to themselves. All right. 1 minus 0.07, and this time we are going to raise it to the 12th. So I'm going to toggle back and forth here for my answers. The first one, $11,191.64. So $11,191.64. $191.64. And the next one, when we did a 12 years, we get 8,371, 8371.93. 8371.93. I think I got that right. Next, determine if the table represents exponential growth or exponential decay and explain. So if you are each of these you're going to, if it's a neither, obviously, but each of these, if you're multiplying by a number that's greater than 1, that's going to be growth. And if you're multiplying by a number that's less than 1, that's going to be decay. So in this case, it's multiplying by 1/3 or dividing by 3. Sometimes people would say that. So this would be decay because, again, it's going down in value, multiplying by the same number each time. Now, this next one is subtracting 6 each time. So that's not exponential growth, that's not exponential decay, that's arithmetic. Okay, that's a linear situation. So this is what we would refer to as neither. And if you actually wrote linear, that's probably the best way to describe that. And the last one here is multiplying times 2. So that would be exponential growth because you're multiplying by a value that's greater than 1. Next one, and this gets a little bit more complicated only because the rate at which it's going and what it multiplies by is a little more challenging to find. If I am just told that this will be exponential, then I basically have to decide 37,000 divided by 29,600 and the rate that it's multiplying by, or but 29,600 divided by 37,000. It's going the other way around. 0.8. Okay, so it's multiplying, or the decay factor is 0.8 raised to the t. And how much does it start off with? It's starting off with so what would the next number be if I multiplied by 0.8? So if I took 18,944 times 0.8, so it's a little harder for me to write my model here because it's actually 1 minus r raised to the t minus 1 because the starting value is at the first year, which messes things up just a little bit. So anyway, 1,894, 18,944, I'm having trouble speaking, times 0.8, so the next value would be 15,155.2. So again, multiplying each time by 0.8. Determine whether it represents growth or decay. So again, you're looking at this initial value here. And if it's above 1, it's going to be growth. If it's below 1, it's going to be decay. And then get the percent. Here's what I tell her. If it's growth, it's 1 plus r. And if it's decay, it's 1 minus r, and then just solve. So if I subtract 1, I get 0.07, which is 7%. If I subtract 1, I get negative 0.02, which means it's 2% decay. You try. So go ahead and hit pause on this one. All right, welcome back. You're going to put $825 into your bank account. 1 plus R, which is 5%, and then they want you to put it in there for 10 years. So if I pulled out a calculator, I did 825, 1 plus 0.05, raised to the 10th power, 1343 and 84 cents is how much money. So $10,000 in a bank, leave it there for 10 years, you're going to come back with 1343.84. So now your homework assignment, I believe the homework assignment for section 6.4 is out of the book. If you're in my class, I believe it's going to be, so check your Google Classroom, but page 319, 5 through 47, odd, skip, so don't do 35 and 39. So these are two questions you're not going to do, 5 through 47 odd. If you have any questions, make sure you talk to your teacher, and good luck.